Installation of a petroleum coke system at Union Camp's number 2 lime kiln, located at Prattville, Alabama, is a major step for this mill and the paper industry in general. Although petroleum coke has its disadvantages, the advantages outweigh the potential problems. Petroleum coke should offer a viable source of lime kiln fuel into the future, as will be shown. Approximately in the center of the pad is an opening through which coke will be introduced into the system. The opening is approximately 9 feet by 10 foot and is covered by a grizzly which has 8-inch openings. Using the front end loader, the coke will be either pushed or dumped through the grizzly to the reclaim hopper below. The number 1 conveyor is the first of 3 long transport conveyors. This conveyor is 136 foot long and rises to a little over 36 feet. The belt is 24 inches wide and is driven at a speed of 250 feet per minute and discharges into the crusher. Just ahead of the head pulley is a magnetic separator that will pick up any pieces of steel that might be mixed in with the coke. This is to protect the crusher, which follows next. The magnet that is being utilized is a Stearns Model 25A electromagnetic cross-belt conveyor. Metallics drop down this chute for subsequent removal. Since the coke will be purchased unprocessed, we may receive pieces up to 6 inches in diameter, and a pulverizer cannot accept anything larger than 1 inch in diameter. Therefore, a crusher has been provided to ensure that no oversized material will be fed to the pulverizer. This shows a typical sample of the pre-crushed coke. The number 2 conveyor is the second of 3 long transport conveyors. The conveyor is 844 feet long and rises approximately 78 feet. The belt is 24 inches wide and is driven at a speed of 250 feet per minute. The conveyor is loaded from the crusher and discharges to number 3 conveyor. A considerable amount of attention has been given to minimizing dusting with this conveyor system. All conveyors have been provided with dust-tight covers, and all other openings have been provided with seals. In the discharge chute of number 2 conveyor, a 10-inch suction line has been provided for a dust transfer fan. This is number 3 conveyor, and it is 70 foot long and rises approximately 15 feet. The belt is 24 inches wide and is driven at 250 feet per minute. A storage silo has been provided at the hot end of number 2 lime kiln that has a capacity of 123 tons. This is slightly in excess of the requirements for one day when burning maximum coke. The silo is 14 foot in diameter and a straight wall height of 25 feet. Load cells have been provided so the weight of the silo and hence its contents can be determined. The weight or indication of how much coke is in the silo will be determined on a control panel.
And into their stump gravimetric feeder. As material comes on, it's weighed and conveyed down the length of the conveyor, down into our chute that goes into our rotary air valve.
Okay, tell me what you're doing now.
Okay, I'm weighing the sample. So I'm going to put the sample in the top lid.
A portable moisture analyzer is next used to determine the raw coke moisture content. First, a sample of coke is weighed in a balance. Next, carbide will be introduced into the pressure vessel so that when it mixes with the moisture, acetylene gas is formed. The pressure of this gas produces a direct reading of coke percent moisture.
the lid, then mix it. I've mixed the reagent and the moisture sample together, and the gauge tells us we have 15% moisture, surface moisture.
The coke will next be dried from the 15% moisture down to 0.3% moisture as it is being ground to 90% minus 325 mesh. Coke offers several advantages for use as a lime kiln fuel. The primary advantage is cost savings when compared to natural gas and number 6 fuel oil. The high heat content of petroleum coke also adds to its attractiveness. Coke usually runs about 14,000 BTUs per pound. Shown here are the kiln's heat exchangers, where the 600-degree Fahrenheit drying gas is obtained for the Williams DF pulverizer. This heat is required to dry the 15% surface moisture from the coke during the grinding operation. The hot gases exit from the top of the firing end of the number 2 kiln and are conveyed through this 24-inch diameter duct past a tempering air damper. This damper allows fresh air to enter at this point if the system temperature goes too high. Both the system temperature and the volume of air are controlled by the Williams 200 series computer, which will be explained later.
The air enters by way of this 24-inch diameter pipe into our wind box. As the air comes into our wind box, it circulates around and comes through what is known to us as porthole liners, or porthole openings in the bottom of the mill. The air enters, it rises, bringing the material with it. The lighter material passes through our classifier and out through the top.
Comes out of the union behind this flexible hose.
Alright.
Travels down the stem.
Okay.
And into the block.
This block, put your hand on it, right there. Now there's pistons in that block that move back and forth and distribute the grease, correct?
That's correct. Grease distributes and goes out of these hoses
Okay.
and into trunnion blocks.
Trunnion block.
Air also travels around the grease hose inside this pipe, comes down through behind the flexible hose,
Okay.
and through a rotary air seal unit.
Alright.
The air then travels through these red hoses
Okay.
and enters into the journal via a check valve here and purges the seal area.
And where does it exit?
The air then exits from behind these flingers.
Okay.
To blow the dust away from the seal area.
Directly above the DF52 pulverizer is the spinner separator. Through the speed of this device, the coke particle size is accurately controlled to 90% minus 325 mesh.
Okay, this is our mill drive. The mill is driven by a 150 horsepower motor that has an AC variable frequency drive on it. It's connected into our spoke coupling right angle gear drive with a 9.
By varying the speed of the mill vertical shaft, the output of the pulverizer can be made to match the input of the feeder through the Williams 200 series computer.
This is a Williams System 200 computerized control system. All the instrumentation you see here is the metering devices, temperature control, manual speed pots, and handheld data terminal.
Please open the case and take that out. Okay, leave the case door open and just pull it out for you.
Okay, the next thing we want to monitor will be differential pressure.
All right, while you pull up the differential pressure, we'll take a look up here as to what it's actually doing. And you're going to pull up monitoring.
It's varying between 6 inches and 6.4 inches.
All right, could you hang that back up and let's take a look at the control panel, and then we'll go under the control panel to look at the computer.
The system is set up so the first thing in sequence that you turn on will be the control power and the computer power together.
Show me the computer.
And the computer is located down in the lower right-hand front corner of the control panel. The computer consists of 3 boards:
Okay, show me the boards. One there.
CPU board, analog input, and discrete I/O and analog output. You will notice there's a very large accumulation of dust inside this panel. That is because this panel is open on the bottom to the operating environment outdoors where the kiln is located at. These boards are all conformally coated to be able to work within these conditions.
All right.
Okay,
Now, what do you got there in your hand?
This is a sample of the product coming to the
Okay.
burner from
You
the
put it down
pulverizer.
right next to the... Okay, put a little more on there. And would you jump? Would you smear? That's what I was looking for. Now, what is the fineness on this?
Okay, the fineness here is 88% minus 325 mesh.
Once the material is fine enough, it travels out the classifier, out the top of it, across through this 18-inch diameter pipe, travels into the exhauster. Once it reaches the exhauster, it's then picked up, transported directly up to the kiln by way of this 18-inch diameter pipe. I'm presently standing alongside the Cohen combination fuel rotary kiln burner. Burner is designed to burn a number of fuels and is presently firing petroleum coke, pulverized with a sustaining natural gas fire. The petroleum coke enters the kiln through this 18-inch pipeline, passes through the 18-inch safety shutoff line, down and into the center of the burner. Primary air for the burner is heated and is being controlled at approximately 450 degrees Fahrenheit and enters through this ductwork controlled by this damper and enters the burner around the outer circumference of the coke stream. Coke stream itself passes down along the center line of the burner and into the firing area of the rotary kiln. The burner is presently firing approximately being petroleum coke. The remainder
The view now is on the tip of the burner. What you should be able to see is a black area called the fuel plume. This is an area of unburned coke just prior to ignition. You may also be able to view streaks in the black coke plume, which are jets of natural gas that are being used to sustain the combustion of the coke. At the end of the black area or plume, ignition occurs and is extremely radiant in color, similar to an oil fire. The fire itself appears to be well defined. We're looking at the number 2 lime kiln, and lime is producing at about a rate of 250 tons a day. The lime's approximately at the hot end 2200 degrees. The cold end temperature is about 560 degrees.
Installation of the petroleum coke system for the number 2 lime kiln is a major step for this mill and the paper industry in general. Although petroleum coke has its disadvantages, the advantages outweigh the potential problems.